Now that we are familiar with circuit elements and their VI relationships, we will go on to look at systematic ways of involving large circuits. Okay. We have already analyzed circuits along the way while working out examples and so on. We have found solutions to some circuits and that constitutes circuit analysis, but the methods we used were ad hoc and easy to use for simple circuits, but cannot be scaled up efficiently for large circuits. Okay. So, for large circuits we need to have systematic ways of analysis and that is what we are going to study. But before we go to the systematic ways of analysis, first we will find out what is it that we have to solve. Okay. Now, let us consider some general circuit. Okay. For now, the function of the circuit is not of significance to us. There is some circuit like this. Okay. Now, this circuit has 4 nodes. Okay. And many branches 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, there are 8 branches. Okay. So, in general when we have a circuit, we will have a certain number of nodes and a certain number of branches. Okay. So, in general we could have a circuit with n nodes and b branches. Okay. Now, what is it that we want to solve? Basically, we want to solve for the current and voltage in every branch, okay, in every element. For now, we will consider 2 terminal elements, but exactly the same thing can be generalized to larger number of terminals. Okay. So, if we have 2 terminal elements, so B branches and each branch can be considered a 2 terminal element, then we will have 2B variables to solve for, basically B voltages and B currents. Okay. So, now we have to solve for 2B variables, B voltages and B currents. That means that we need 2B independent equations. So, if we have a circuit with B branches and each branch constitutes a 2 terminal element, then we need 2B independent equations. We have to somehow generate them from circuit laws as well as the element behavior, and then if we solve for these equations, we will find the solution to our circuit. Okay. So, this is what is meant by completely solving for a circuit. Now, in the problems given in assignments or in books, you may not be asked to solve for everything. That is, if you have 5 resistors and 2 voltage sources, maybe you will not be asked to solve like 7 voltages and currents, but in general that is what is meant by solving for the circuit. Okay. So, in particular problems maybe some current is of more interest than the others, but the general methods we look for we will try to solve everything in the circuit. Okay. Now, How do we get these? What are the principles we use to solve our circuit? We have Kirchhoff's current law at every node and Kirchhoff's voltage law around every loop, and finally, these are of course general properties of all circuits. Finally, we have the specific properties of elements in our circuit, and we have VI relationships for each element. Okay. So, these are what we have to use to solve our circuit.